Chapter 2, Section 2.3, Polynomial and Synthetic Division. Here are our section objectives. And we'll start with long division of polynomials. Long division of polynomials is something we typically use to kind of break it down and factor it, try to find some zeros, try to get some more information from a polynomial versus just in general form. And so here it gives us a polynomial, and then we can see the graph. It says that one of the zeros is 2. That means if one of the zeros is 2, there is a factor of 2 in this polynomial. So if we were to divide that out, we would want to see what's left. So here's the factor that we could factor out or pull out, and then q of x would be what's left. That may be factorable as well. So what we're going to do in order to pull out that factor or divide out that factor is use long division. So long division of polynomials, we started with the original polynomial and we want to divide out a factor of x minus 2. We are going to do this very similarly to how we divide numbers. So this is an example unrelated to this problem. Let's say we had 147 divided by 5, and we wanted to break that down into a mixed number. We take the top of the fraction, put it under this divisor sign, we take the bottom, put it out in front, and then we start long division. So we think, how many 5s go into 1? Well, it's too big, so let's do it again. How many 5s go into 14? 2 of them. We multiply 2 times 5, and then we subtract. 14 minus 10 is 4. Then we drop down the 7 and we start over. How many 5s go into 47? 9. 9 times 5 is 45. And so we end up, done. We have a remainder of 2. So 29 remainder 2 would be 29 and 2/5. The remainder is 2. The denominator stays 5. So you can turn an improper fraction into a mixed number using long division. That is kind of what we're going to do here. We are going to take our polynomial, we're going to put it under that dividing sign. So 6x cubed minus 19x squared plus 16x minus 4, and we're going to divide out our x minus 2. So instead of saying how many of these go into this, we're going to say what times x minus 2 would give us a number so that when we do our subtracting, it subtracts to 0. So when I'm picking what to do first, I'm going to say what times x minus 2, or just x, what times x would give me 6x cubed. So the answer to that is 6x squared. 6x squared times x would give me 6x cubed. Now I like to keep my terms aligned vertically, so that's why I wrote my first term right above the 19x squared. I wrote 6x squared. So that's my picking part. Now I'm going to do the multiply part. 6x squared times x is 6x cubed. 6x squared times negative 2 is minus 12x squared. That's my multiplying part. Now I'm going to do my subtracting part. 6x squared minus 6x cubed minus 6x cubed is 0. That's what I wanted. Negative 19x squared minus negative 12 or plus 12x squared would be minus 7x squared. Then we drop down the 16x and we start over. So again, I'm like, what times x would give me that front term? What times x would give me negative 7x squared? And that would be negative 7x. Then I'll multiply and subtract. Negative 7x times x is negative 7x squared. Those match. They'll subtract to 0. Negative 7x times negative 2 is plus 14x. That was the multiply. Now we subtract. Negative 7x minus negative or plus 7x squared, those cancel out. 16x minus 14x would be 2x. Pull down that minus 4, and we'll start again. What times x gives me 2x? That would be plus 2. Now I'll multiply and subtract. 2 times x is 2x. 2 times negative 2 is negative 4. When I subtract these, they both go to 0, so my remainder is 0. So when I did, the polynomial divided by x minus 2, this was my result. Now, when I showed you long division, I wrote it as a mixed number. What I'm going to do here is if you take this, and you divide by this, you're going to end up with, I'll rewrite it all. 6x cubed minus 19x squared plus 16x minus 4 equals the factor that you pulled out times the factor that you have left. And there's no remainder, so that's it. Now, if this is factorable, we can just continue. So we'll see. X minus 2, and then it's either 6x and x or 2x and 3x. I'm going to hope for 2x and 3x. 2, I could do 2 and 1. Let's try 1 and 2. They both have to be negative, and that works. So factor the polynomial completely means whatever you have left. If it's factorable, you just keep on factoring, and we ended up with 3 factors. Here is our long division typed out, and then we had done that. The division algorithm just kind of shows you how you deal with your remainder. You start with your big polynomial, you have your, your divisor, your quotient, and then plus your remainder. Here's another way to write it. Kind of different, improper fractions, proper fractions, using the idea of dividing polynomials and then writing their answers in different forms.